Hello everyone, today I'm going to be introducing you to the TigerGraph Machine Learning Workbench. The ML Workbench provides a better way to develop graph neural networks utilizing the connected data store in a TigerGraph database. We've seen recent publications and research showing the success of GNNs in outperforming traditional machine learning methods across many domains. If you are looking to apply this industry-leading data science technique to your business application, then the ML Workbench is here for you. The ML Workbench is a Python development framework that allows you to quickly develop your own GNNs. It is natively integrated with TigerGraph, a native distributed MPP graph database, which means you can easily manipulate, process, and export your graph data with speed. The ML Workbench is platform and framework agnostic, meaning it can easily be plugged into your existing ML infrastructure, such as SageMaker, Vertex AI, and Azure. And it will work with your existing ML pipelines leveraging PyTorch Geometric, DGL, and TensorFlow. Not an expert in graph query languages? Don't worry, ML Workbench has you covered. The Workbench provides graph data processing capability such as training and test splitting, subgraph sampling, and mini-batching for your GNN training at a Python level. So you do not need to spend any time learning any new query language. You can just focus on the data science that you've already been doing and the Python code that you've already been writing. Let's dive into a working example. Here we are in the ML Workbench interface, and in this demo, we will be using the Cora dataset, which contains about 3,000 academic research papers. We will be using a variation of a graph neural network called GraphSage to make topic predictions of an unlabeled paper in our dataset. In order to train our GNN, we first need to prepare our training, validation, and test datasets. The important part of graph data are those relationships between the different nodes in the graph, and just randomly dividing your data can break the connectivity between those relationships, and this would be bad because it kind of defeats the whole purpose of using a GNN in the first place. It's by calling the split vertices function. It will partition your graph into different buckets according to your desired percentage split, while still preserving the graph's connectivity. Our graph data loader function interacts directly with the TigerGraph database and exports your graph database into your environment and automatically converts your graph dataset into PyG, DGL, or TensorFlow format so that you can directly leverage these deep learning frameworks. If you're working on a huge enterprise-level dataset and having difficulties leveraging the whole graph to train your model, well, then the ML Workbench also comes with different flavors of subgraph sampling methods. Our neighborhood loader function can help create subgraphs according to your sampling strategy so that it can generate batches of subgraphs, enabling you to do stochastic training processes even without an exotically powerful machine. As you can see, ML Workbench democratizes the GNN development experience. We've taken care of all graph traversal and processing logic and provide the user with a high level of interaction within a Python environment. For more details about the Machine Learning Workbench, its other capabilities, tutorials, and working examples, please check out tigergraph.com/ml-workbench. Thank you very much for taking the time to become introduced to the ML Workbench, and I look forward to seeing the projects that you create by utilizing it.